Welcome to the Discovering Agilent SystemVue video series. This tutorial will familiarize you with the basic operation of the SystemVue C++ code generator that is new to the SystemVue 2010 release. This video will highlight features of the W1461 SystemVue Communications Architect base product, as well as the W1718 C++ code generator. SystemVue 2010 now supports C++ code generation for creation of floating-point C++ models and compiled Windows 32 DLLs from SystemVue schematic models. These schematic models support any user-defined custom model built using SystemVue C++ Model Builder interface. These models can also be built from commonly used DSP and signal processing blocks that are available as standard features within SystemVue. The C++ code generator supports both licensed and unlicensed model generation. The built-in models that support C++ code generation are contained within the algorithm development library under C++ code generation models. These models include basic blocks like adders, gain blocks, and subtractors, as well as higher-level communication signal processing functions like OFDM modulators, demodulators, coders, and encoders, etc. To explore the functionality of the SystemVue C++ code generator, we will look at a simple design of a cascade integer comb or CIC filter that we've created in SystemVue. Here you can see I've already created the schematic for a two-stage CIC filter that implements a low-pass response. By simulating this filter, we can take a look at the low-pass response just to validate that the design is indeed working as expected. To start the C code generator process, I can simply just export each one of these models individually, or I can gather up these models and convert these models into a subnetwork by selecting the models, right mouse clicking, and selecting Convert to Subnetwork. Here I could type in a custom name for the new subnetwork model that will be added to my workspace. I've already pre-created that model, and I will just open it up, and you can see that it shares the same architecture as the CIC filter that it was created from. To validate my subnetwork model, I've created a new design to simply diff the output of the new subnetwork CIC filter model from the original top-level model and output that result into a display. So if I just hit the simulate, go to my workspace tree, open up the new graph, we can see that the output is in fact 0, which means the new subnetwork model is exactly the same as the original design. I can now use that same top-level design for validating my subnetwork to target the new subnetwork to C++ code generator. To do so, I go to my workspace tree and I need to add a C++ code generator controller to my workspace. To do so, simply right mouse click, select Add, C code generators, and add C++ code generator. The C++ code generator UI allows me to select the top-level design for which I want to export models for C++ code generation, as well as select individual models that I want to export. I've already added the subnetwork model that we created in the last step, and if I wanted to add additional models, I can simply do so by selecting the Add button and selecting the appropriate models that I want to export. I also need to select the proper shell type. In this case, I'm going to select a SystemVue model shell type to generate a compiled DLL that can be used as a standalone and portable library within the SystemVue environment. Once all the correct parameters are specified within the C code generator UI, generation of all the required source code files can simply be done by selecting the Generate Now button. SystemVue will simulate and generate all of the required source code files to the file system of your PC. Based on the directory setting within the C code generator UI, SystemVue generated a new folder called CodeGen_CIC filter, where it has also created a SystemVue folder which represents the shell type that we selected, and within the SystemVue folder you can see the C++ header file, XML file, and other Microsoft Visual Studio project files that were created automatically by the C code generator process. Also within the C code generator folder there is a Microsoft Visual Studio solution file that was created by the C code generator, which contains the full Microsoft Visual Studio solution where we can build our DLL. To build the SystemVue dynamically linked library, we simply need to open the Microsoft Visual Studio solution. And within Microsoft Visual Studio, we simply select the SystemVue project that again was automatically created by the SystemVue Code Generator project, and right mouse click and select Build. And here you can see in the status window that Microsoft Visual Studio is compiling and generating the dynamically linked library from the SystemVue generated code. Also within Microsoft Visual Studio, should you want to modify the C source code, if you own the W1718 product from SystemVue, you can actually see the C++ code and modify and add any additional C++ code that you would like to this file. Now that we've created the dynamically linked library from Microsoft Visual Studio, we need to link it to SystemVue by going to the Library Manager, which is accessible from the Tools menu within SystemVue, selecting Add from File, and then selecting the DLL that was created by Microsoft Visual Studio. Now note that that DLL is contained in a new folder created by Microsoft Visual Studio under the original C code CIC filter generation folder that SystemVue created during the C code generation process. Within the debug SystemVue folder, I can see the DLL, select Open, click Close, and now that DLL is associated with SystemVue. To access the new library that was linked in through the SystemVue Library Manager, I could either use the SystemVue Parts Selector to select the C code generator library, which is now enabled by linking that DLL, and selecting the part or parts that are in that library by selecting it from the Parts Selector and dropping it within my schematic, or I can simply associate the new model to my subnetwork model by double-clicking the subnetwork model, selecting Manage Models, Add Model, Model from Library, and then selecting the library that was created, again by linking the DLL from Microsoft Visual Studio, and I can associate this new model to my subnetwork model, and I now have two different models that I can select, both the original subnetwork model and the new compiled C code model from the dynamically linked library. So I'm just going to select the new dynamically linked compiled C model, and I will rerun the simulation, and we will view the same result that is showing the difference between the original top-level model and the new compiled model. And again, as you can see, that result is 0, which means the new compiled model does indeed match exactly the original subnetwork model that generated the C code. So to summarize, in this video we covered the basics of using the C++ code generator within the SystemVue 2010 product. We demonstrated how the C code generator can be used to build model libraries that are both portable and protected for use within SystemVue or other third-party tools. We quickly built a reusable SystemVue library that can be deployed within a workgroup or within your customer base. We also demonstrated how Microsoft Visual Studio is integrated within the C++ code generation process to build dynamically linked libraries that can be used by SystemVue or by other third-party products. For more information on Agilent SystemVue, please visit www.agilent.com/find/SystemVue. From this link you can learn more about SystemVue product and SystemVue features, as well as request an online evaluation and license for the SystemVue product and the C code generator. Thank you very much.